Everybody, welcome back to this section 2.6 video. In this video, we're going to take a look at another example using Euler's method. So consider the initial value problem. Y prime equals 0.1 times square root of y plus 0.4 x squared with the initial condition of y of 2 equals 4. Okay, we want to use Euler's method to get an approximation of y of 2.5. Okay, so we want to get our step size up to 2.5, and we're going to use a step size of zero point 0.1 and 0.05. Okay, so let's just remember a couple things of Euler's method. Okay, that y n plus 1 equals y sub n plus h times f of x, y. Okay, and just remember that this part right here of our differential equation is our function of x and y. Okay, and another thing to remember is that our initial condition gives us our first approximations we can use. So x of 0 and y sub 0, we have the point, 2 comma 4. We can use these to get our approximations going. So it's saying use h 0.1 and h 0.05. So those are our step sizes. So let's set these up. So for our step size, h equals 0.1. Our Euler's method would look something like this. Y sub n plus 1 equals y sub n plus our step size 0.1 times our function in terms of iterations 0.1 times square root of y sub n plus 0.4 times x sub n squared. Okay, so that is our approximation with a step size of 0.1. And so what would a step size for, our setup for a step size of 0.05 be? Well, it would be pretty much the same thing, except it would be plus 0.05 times our function of x and y. Okay, so this is our setup, and what I want you to do is see if you can get our approximation of 2.5. So when x is 2.5, what is y going to be? What's that approximation? So pause the video and see if you can fi figure these out, and also create a table for your summary of findings. Okay, so let's pause the video and let's try that out. Okay, everybody, welcome back. So hopefully you tried these problems out and you were able to fill out a table correctly. So for a step size of 0.1, you should have gone up to n equals 5 appro iterations and got your 2.5 and an approximation of 5.0768. So what that's saying is y of 2.5 is 5.0768. Okay, so that one's a little easier to do than the step size of 0.5 because this one took a quite few more approximations, notably double. Okay, so you eventually get to one. So y of 2.5 is 5.0997. Notice how the approximations are a bit different. That's because of the step size. And typically the smaller the step size, the closer the approximation, with less room for error. But hopefully you try these problems out. Sometimes it's best to just do a table and do the calculations in your calculator, or other technology that you use. But hopefully, you got similar results. So that's it for this video. I'll see you in the next one. Thank you for watching.